Alright, this is day 28 of solving math problems until a whole life member notices me. So pretty much we have sine of x plus cosine of x is equal to what? Right? We pretty much want to know what this expression here is simply equal to. Well, I'm going to go ahead and show you that we could express this as a singular cosine function and a sine function. So let's just go ahead and do this. And here, I'm going to solve for just the sine part, right? So we're going to assume that sine of x plus cosine of x is equal to a sine of x plus b, okay? And here, we're going to expand the right side using the sum formula for the sine function. So we have sine of x plus cosine of x is equal to a times sine of x cosine of b plus, let me just fix that, cosine of b plus sine of b and cosine of x. Okay? And pretty much here, I'm going to expand a and make the equation, right? So we have sine of x and cosine of x in pretty much both factors, right? So we could rewrite this as sine of x is equal to a sine of x cosine of b, and cosine of x is equal to a sine of b cosine of x. Okay? So, with this in mind, we could pretty much cancel out the cosine of x in the second equation and sine of x in the first equation, which is going to pretty much leave us with 1 is equal to a cosine of b, and 1 is equal to a sine of b. And you would ask, but there's one problem. How do we find a and b, right? Well, we pretty much can find a and b, right? We could go ahead and do it the long way and make a long substitution and do a bunch of work that is unnecessary. But we're not going to do that. What I want to do, right, is pretty much square the top and bottom equation, right? So that if we add pretty much both equations, if squared, is going to give us 2 is equal to a squared, because sine squared plus cosine squared is 1, where a is going to be the square root of 2. Okay? And if we replace a with root 2, we're going to have, let's say, we're going to do the cosine function. So we have cosine of b is equal to 1 over root 2, which is root 2 over 2. And here you could assume and say, okay, b is equal to pi over 4, because we know that cosine pi over 4 is equal to root 2 over 2. So now that we found a and b, we could pretty much make our conclusion that sine plus cosine is equal to the square root of 2 times sine of x minus pi over 4, or plus pi over 4. So yeah, that's pretty much the solution in terms of sine. And now we're going to do the same thing we did, but just with the cosine counterpart. So we're going to assume that sine of x plus cosine of x is equal to a cosine of x plus b. Okay, so the right side was simply going to become a times cosine of x cosine of b minus cosine, or not cosine, sine of x and sine of b. And that is equal to sine of x plus cosine of x. We're going to go ahead and do the same thing, right? Pretty much make the system of equations, which is going to be sine of x is equal to a sine of x sine of b. And since we're going to multiply by negative, that's going to be negative sine x. And the sine x's cancel out, right? And the same thing can be said for the cosine, since we have cosine of x is equal to a cosine of x and cosine of b. And those cancel out as well, just leaving -1 is equal to a sine of b, and 1 is equal to a cosine, or sine, no, cosine of b. So pretty much we see that if we square, the -1's going to go away. So we can already say, okay, a is equal to the square root of 2. And pretty much now what we have to do, right, is we're going to have the system of equations, so we have cosine of b is equal to root 2 over 2, but sine of b is negative root 2 over 2. And that means that pretty much it has to be in the fourth quadrant, right? Pretty much theta, or pretty much b, has to be greater than 3 pi over 2. So pretty much what we can do, right, is say, okay, so we have that b could be equal to 7 pi over 4 because that is in the fourth quadrant. So we say that b is 7 pi over 4 because if we have sine 7 pi over 4, that is negative root 2 over 2, and cosine 7 pi over 4 is positive root 2 over 2. So with that, right, we pretty much found cosine as well. So we here finally could say that we have root 2 cosine of x plus 7 pi over 4. B could also be negative pi over 4, but pretty much if we add 2 pi to that to make it positive, we're going to end up with 7 pi over 4, which is the same thing. So yeah, we're just going to leave it as 7 plus 7 pi over 4. Or you can also rewrite this as root 2 cosine of x minus pi over 4, and the only thing you see is, the only thing that changes is just the function and the sign in front of this, the x. So yeah, we finally were able to show that we could express sine and cosine simply as either just one singular function of sine or one singular function of cosine. So yeah, that's pretty much all that we were going to show, and we finally solved the problem. And just to try something new, let's say I want you to try this problem. Solve for x here. So you have that, and that is equal to root 3 plus root 2 over 2. So yeah, just go ahead and try this problem out. and you could use whichever formula on screen. And yeah, that's pretty much it. So thank you for watching, and with that, I say bye bye.